is going to be distribution of data. Okay. Now, the data can have three, what can I say, maybe three situations in terms of distribution. So, the first case, which is an abnormal case, we have got symmetrical data. Symmetrical data. Now, this one here, if you draw the box and whisker, okay, the distance between the median Q2, okay, and okay, this is just an example, by the way. With symmetrical data, right, you have a scenario like this. You have your Q1 here. Let me use a different color. So you have your Q1, Q2, which is the median, and Q3, which is the upper quartile. Can you please do me a favor? You need to pay attention. From my experience, learners can do well in geometry, but answering questions on statistics can be a problem. Okay, especially this part which I'm doing on distribution of data. Right? Now, if the data set is symmetrical, okay, what that means is we can explain it in terms of the quartiles, or we can explain in terms of the mean. So the first scenario is the mean. If this is the case, it means your x bar will be equal to Q2. Okay? Remember, x bar is the mean of the data set. So if the data set is symmetrical, okay, it means that the mean will be equivalent to the median. And that case now, in real life, it is very, very rare. Okay? It's very, very rare. Okay? Also, we can explain it in terms of the distance between the quartiles. So, Q2 minus Q1 will also be equal to Q3 minus Q2. So what this means is the distance on the box and whisker between the median and the lower quartile will be equivalent to the distance between the upper quartile and the median. Then you can say the data set is what? Symmetrical. But of course, that can also have the whiskers can also have an impact in terms of the minimum and the maximum. But generally, that's the scenario. Okay, normally we consider number one, okay, but number two as well, we can also use. Okay, he started first. Yes. Yeah, in that case now, that's why I'm saying in a case like that, then you concentrate on the difference between the mean and the median, which means the mean must be equal to the median for you to say the data set is what? Symmetrical. So focus on that. But sometimes we may need to use that as well. Okay? And as I showed you yesterday, you see this yesterday, I showed you yesterday. Was it yesterday, the day before yesterday? The box and whisker which I drew, okay, we had a situation where the data set, I think it was skewed to the left. Am I right? Now, of course, the box and whisker itself, the length or the value of the maximum and the minimum might have an impact, okay, in terms of the distribution. But we normally use the pattern. Okay? We normally use the what? The pattern. But the difference between the mean and the median is 0 when the data set is symmetrical. Yes?
So if the mean is equal to the median, but Q2 minus Q1 is not equal to Q3 minus Q1, are we still right in saying that the data set is symmetrical?
Yes. As long as the mean is equal to the median, then we can conclude that the data set is what? Symmetrical.
And if the
There are some
second
cases where you have a situation like this, okay, whereby because of the minimum and the maximum now, that can have an impact in terms of the distribution. Okay, but you can have, so, okay, just to avoid confusion, number one is the basic criteria in terms of what? Symmetrical data. So that's clear to everyone. Number one, the best what? Criteria to determine whether the data set is symmetrical or not. Okay? Number two, we can use it, we can have some cases where it might not be a very good criteria, especially if the difference between your upper quartile and your maximum is too long, and also on the other side where the distance between your minimum and your maximum is also too long or probably too short as well. Okay, so let's use the first criteria in most cases. But the second one also helps in terms of determining the distribution of a data set. I hope I've answered you. So the criteria number one is the best.
I completely understand everything that you said. But what if we get a situation where the second case is true and the first case is not?
If the first case is true, the second case is not.
If the second case is true and the first case is not, is it possible to get a situation?
I think it could be, but in that case now, because the first criteria or the first case is the best of the two, then you have to use the first one. Okay, use the best one. But in your case, for your high school, that's a very rare situation. But if you are in the real world now, if you are a statistician, maybe that's when you can account a situation like that. But for you guys, most of the time, both these two criteria, they work. Because most of the data set that you encounter either is skewed to the left or skewed to the what? To the right. So these two will work at this stage. Right? Then we have got, so this is, now, okay, just to let you know as well, when you draw in a case like this where the data is symmetrical, then in advanced statistics we say that the data follows a normal distribution, which is also rare. Okay? We say it follows a normal distribution into this like that. Unfortunately, your curriculum, you don't do distributions in more detail. It's a what can I say? It's a branch of statistics which is a little bit more advanced actually. That one there. But that's a normal distribution which is very rare in real life. Okay. Okay. Then the second scenario or situation, you can have data set which is skewed to the left or skewed to the right. Skewed to the right. Let's start with right first, or we can say positively skewed. Okay. Now, with this one, generally when it comes to the box, it will look like this. So you have now your median is somewhere there. So we can have the whiskers. So we have Q1, Q2, and then Q3. If the data set is skewed to the right or it's positively skewed, it means the difference between the mean and the median will be positive. So X bar minus, or rather, okay, let me just use inequalities. So X bar will be greater than Q2. Okay? The mean will be greater than the median if the data set is positively skewed. So if you are given a data set, you see now with the classwork, if you are asked to comment on the distribution of the data, you must check your mean, or you must determine your mean and your median. Sometimes you need the quartiles as well. So for this case now, the distance between Q3 minus Q2 will be greater than the distance between Q2 minus Q1. Okay, so the data set will be positively skewed. Any of these two. Okay? Like I told you about the grade 12 standardized test. People were complaining that after the test was very difficult. For some reason, if Mr. Chiponda sets a test, people generally feel that it's very difficult. No, I don't know.
It is.
Huh? As long as I set the paper, people say it's difficult. Okay. So some people were complaining. Then I said, okay, we cannot rush to say, let's give you another test. The best way is to mark the test, then have the results. Let the results tell us that indeed the paper was what? Difficult. Okay. Yeah, you can write the test and then start saying, this was difficult, we need to write a new one. No. That's what happens. Okay. The paper has to be marked first, and then after that, you analyze. That's where statistics comes in. Okay? Are you following that? It's interesting, isn't it? And then I've got 58 learners metric. Okay, 58 of them. So just to tell you. Alright. Okay, let's carry on. So we also have skewed to the left. Now, if the data set is skewed to the left, we call that negatively skewed. Negatively skewed. So in that case now, the median will be very close to the upper quartile. So you have a scenario which looks like, okay, so you have your Q1 here, then Q2 there, and then Q3. So in terms of the criteria for finding whether the data set is positively skewed, negatively skewed, and so on, in the case of negatively skewed, it means your X bar will be less than Q2. So your mean will be less than the median. Okay? Generally, like for a class like this, it won't be a good thing to have a median which is higher than the mean. Okay? Also, the distance between Q3, okay, Q3 minus Q2, this one here, will be less than Q2 minus Q1. Okay? Just to give you more information with regard to this. You know that when you write metric, the results for each subject, they're also analyzed. Yes, they're also analyzed. And then